Okay, today we're going to do Chapter 1 review. It's going to be a review over the Chapter 1 that you did last year at the beginning of the year. Okay, the first example, what they want us to do is they want us to solve each of these problems whenever my variable y is equal to 3. So all I need to do is plug it in and solve. Now, when you plug it into this first problem, you do not write it side by side and get 43. Anytime you see a number right beside a variable, it means multiply. So I would do 4 times 3, which is 12. Okay? Keep going down, and I'm going to do 12 divided by 3, which is 4. And 3 plus 8, which is 11. And 18 minus 3, which is 15. So all I needed to do there was plug the 3 in for the variable of y and solve for each of these problems. The next type of problem that we're going to do is order of operations. And what order of operations stands for is parentheses, exponents, multiplication, division, addition, and subtraction. Sometimes you've heard it called, please excuse my dear Aunt Sally, or PEMDAS, okay? What this gives us is it gives us an order to do our math problems in, because a lot of times you have lots of different steps to do, and if you don't know what step comes first, you can get different answers, okay? Just like if I were to give you this problem, 5 times 2 plus 3. Okay, order of operations says I do 5 times 2, which is 10, then plus 3, which is 13. But if I don't do it in order of operations, let's say I did 5 times, and I went ahead and did 2 plus 3, which is 5. What's 5 times 5? 25. That is not the same answer, and it is not correct. Okay, so we have to do order of operations in order to get the right answer. All right? Now, one thing I do want to tell you that I did not write on here is there is a thing called the left to right rule. I want you to write this down. Left to right rule. And what the left to right rule says is that multiplication and division are equal and addition and subtraction are equal. Now, just because it's listed M, then the D, and then A, then the S, doesn't necessarily mean that I always have to do multiplication before division. It means I need to do it as I see it, as I read it left to right. So if I had a problem like 27 divided by 3 times 2, what I would want to do is they tell me multiplication and division are equal, so I just need to read them from left to right and solve it. So I would do 27 divided by 3, which is 9, times 2, which is 18. So I would just do left to right, okay? Same exact thing with addition and subtraction. So I would have 2 plus 3 minus 5. So I would do left to right. 2 plus 3 is 5. 5 minus 5 is 0. Okay, so that's my left to right rule, so remember that. Okay, so example number 2, they want us to use order of operations in order to solve each of these problems. Now, they've got a lot of steps to do in these problems, so that's why we need order of operations. Now, just ignore this little bullet point here. It just automatically got put in there. It doesn't mean anything, okay? So we have 5 times 3 squared plus 7 minus 5. So what I want to do is I want to think about order of operations. And I need to do parentheses first. Now, look at this problem. You see parentheses here. However, that is not the parentheses the order of operation is talking about, okay? Order of operations parentheses means there is something inside of the parentheses that needs to be done. So in order for it to qualify as parentheses in the first step, there has to be more than one number inside of parentheses. If there is only one number inside of parentheses, who can tell me what operation does parentheses signify? Anybody? If I were to write something like this, what would you tell me to do? Multiply. Exactly. So that goes under the multiplication step. So I want you to remember that, okay? So, do I have any parentheses in this problem that I need to take care of? Nope, because there's no parentheses, with more than one number. So I move down. Exponents, all right? Do you see any exponents in this problem? Yes, so I need to do that first. What is 3 squared? 9. So now I have 5 times 9 plus 7 minus 5. So we skipped parentheses because there was none. We did exponents. Now I'm on to multiplication. Do you see multiplication in this problem? Yes, 5 times 9. So I do that next. 5 times 9 is 45. Plus 7 minus 5. Now, the only operations I have left are addition and subtraction. And remember, those are considered equal. So I just go from left to right. 45 plus 7 is 52. 52 minus 5 is 47. And that would be my final answer. Okay? So let's do this next problem. Then we're going to use order of operations again. And remember, look at this problem right here. What I have is I've got brackets on the outside and parentheses on the inside. Now, parentheses and brackets are basically the same thing. But the reason why they do them differently is so that you don't get confused. Because if I had 4 sets of parentheses, you might say, well, what two go together? I don't know. So that's why they use brackets to tell the difference. But when you have an order of operation problem, what you want to do in order to go first, or to find out what to do first, is you find the innermost part of the problem. So you find the innermost parentheses, which is right here, and I do that first, okay? Devin, what would I do? Which gives me what? 14, okay? All right. So I just rewrite the rest of the problem. Okay. What would I do now, Dominic? Not brackets, not yet. Exponents. Yes, because right here, look at this. That symbol's multiplication because there's only one number inside parentheses. All right, so 14 squared. So let's plug that into our calculator because that's a little too much math to do in your brain. Okay, we get 196. So now I get 2 times 196 divided by 4 plus 3. All right, I need to multiply. What's 2 times 196? 392. Divided by 4 plus 3. Once I've taken care of what's inside of my brackets or parentheses, I can drop them. I don't have to keep them on there. Okay? 392 divided by 4 is equal to 98. And 98 plus 3 is equal to 101. Okay, in the next example, what they want us to do is they want us to use that left to right rule. Next example, what they want us to do is use the left to right rule. So I want you to go ahead and work on these, and then we'll go over what answers you get. All right, Tommy, tell me, what did you do for the first problem? You subtracted, so I'm going to do 32 minus 16, and I get 16. Plus 2, what would my final answer be? 18. Very good. All right, Devin, what did you do on the second problem? Divided. 48 divided by 3 is 16 times 2 is 32. Very good. All right, Danielle, what is the last one? What would I do first? Perfect. Look right here. You have division in the middle. That division has to come before the addition or subtraction. Okay? 6 divided by 3 is 2. Then what would you do? left to right, and I would get
14 minus 2 equals 12.
perfect. Very, very good. All right. Okay, next example is they want me to find out are these numbers going to be solutions to the equation or inequality that you have been given. So on the first one, they want to find out, is 60 going to be a solution to this problem? So what I want to do is I want to take 60 here and I want to plug it in for the variable that I see in the problem. I'm just going to solve this side to see if it equals this side. Okay, so let's do that. Let's plug it in. So I'm going to do 12 times, I'm going to plug in that 60 for S, plus 5. And let's see, is it going to be equal to 125? So really, this right here is the only thing I need to solve, because I already know that something is equal to 125, and I just have to see if it's going to. Okay? So what you want to do here is you want to do 12 times 60 first, and then I get what? So it's 720, and then plus 5. Let's already see. Is this going to be a solution? No, because 725 does not equal 125. So no, it's not a solution. Okay? Now the next problem, they want me to decide whether 3 is a solution to each of these inequalities. Now the inequality means I have a greater than or less than sign. Okay? And it's not going to be the same as an equation, because if I do not, on an equation, if I do not get the exact number that I have on the other side, then it's definitely not a solution. But when I have an inequality, you have to check, is 2 less than 5? Yeah, so that's a solution, okay? It doesn't have to be equal. So let's plug in the number 3 for our variable and see if it's a solution. So we would do 3 times 3 minus 2 is greater than 5. 3 times 3 is 9, minus 2 is greater than 5. What's 9 minus 2? 7. Nope. Yeah, 7, sorry. 7 is greater than 5. So is this a solution? Is 7 greater than 5? Yes. All right, let's try the next one. Let's plug it in. 3 plus 5 is less than 8. What's 3 plus 5? Is 8 less than 8? No, so this is not a solution. All right, so the next example that we're going to cover is turning an algebraic sentence into an actual problem. So what you need to know first are math words. What word symbolizes what operation? So some words that you know that symbolize addition are sum, which means the answer to an addition problem. More than, so if I were to say 2 more than 5, I would write 2 plus 5. Plus, obviously, 3 plus 6, I would write it as 3 plus 6, all right? And increased by, 7 increased by 2, I would write 7 plus 2. Subtraction, some words are difference. Difference means the answer to a subtraction problem. Minus, 7 minus 2, I would write it as 7 minus 2. Less than, if I were to say 7 less than 2, I would write 7 minus 2. Also, decreased by, 7 decreased by 2, 7 minus 2. Multiplication, product means the answer of a multiplication problem. Times, obviously, 7 times 2, I would write 7 multiplied by 2. And then multiplied, 7 multiplied by 2, I would write 7 times 2. Division, quotient means the answer to a division problem. And then divided by would be 7 divided by 2, I would write 7 divided by 2, okay? So each of these words are going to simplify a different operation in math. Now, some other math words is the word is. Anytime you see the word is, it means equal. However, when I'm dealing with inequality signs like less than or greater than, if I were to say is less than. Now, if you remember on the last slide right here, we said that the word less than dealt with subtraction right here. But when it has an is in front of it, just like on this one, okay, it means the less than sign. So anytime you see is less than, it means the less than sign. When it just says less than, it means subtraction, okay? Is less than or equal to means less than or equal to, that sign. Same thing with greater than. Greater than can mean addition, but when it has the word is in front of it, it means the greater than sign. Is greater than or equal to means greater than or equal to, okay? Some other words here are some inequality symbols just to kind of brush up your memory. Less than. If you look at it, it makes an L. Okay? An easy way is another way to hold up your fingers, your thumb and your pointer, and these make the signs. And whichever one is an L, that's less than. The other one's greater than. Okay? So greater than is this way. Less than or equal to also makes an L, but it has the equal to sign underneath it. Greater than or equal to, opposite. Okay? All right, so what we want to do now is I want to translate these sentences into a math problem. Okay, I want to translate it. So 6 less than 4 times a number. So I want to write it as a math problem. Now, before I do anything, I want to find out my math words. Less than, right here. 6 I know is a number, but this word less than, is it going to mean subtraction or a less than sign? Who knows? Subtraction, exactly, because does it have the word is in front of it? No. So I know it's subtraction. But here is the tricky thing about the words less than. Anytime they give you the words less than, whatever is before it, 6, the subtraction sign comes before the number. Always. Anytime you see the word less than, go ahead and know I'm going to put that minus sign in front of whatever came right before it. Okay? So anytime you see the word less than. Every other subtraction problem is normal. If it were to say 6 minus 5, I would write 6 minus 5. Okay? But because it says less than, I put the subtraction sign in front of it. Now, I've got 4 times a number. So I'm going to do 4 times, do I know what the number is? No, so I just write a variable. And that goes before the subtraction sign. Okay, and this would be my problem here. Okay? All right, the next one, the sum. What does the word sum mean? Look back at your math words that I gave you. What does the word sum mean? Addition, but more specifically, it's the what to an addition problem. Anybody remember if I were to say the sum of 4 and 6 is 10, it means the answer to 4 plus 6 is 10. So the sum is an answer to an addition problem. So the sum of 8 and a number. So I just want to add them together. 8 plus a number. What's my number? I don't know, so I write a variable. And you can choose whatever variable you want. You can choose an N, you can choose a D, you can choose an A. I don't care, okay? As long as it's a variable. All right, next one. 3 more than the difference of 5 and a number X. Okay? 3 more than, so I'm going to do 3 plus the difference. This word difference right here means what? Look back at your math words. Subtraction, but more specifically, the answer to a subtraction problem. So I'm going to add 3 to the answer of 5 minus X. And I have to put parentheses around that because I'm adding 3 to the answer of 5 minus X. So I've got to do 5 minus X first, and then I can add that 3 to it, okay? And lastly, a number x decreased, so I know it's subtraction, by the quotient. Quotient, what does that word quotient mean? Division. Most specifically, the answer to a division, so I need to put in parentheses, of 5 divided by y. Because I know I need to do 5 divided by y first and then subtract it. Okay?